All right. Hello, everyone. Thank you for joining me today, and welcome. Welcome. We are going to keep working on our compiler today, and my goal for today is to actually get something useful done and probably finish the AST, the abstract syntax tree of the compiler. And this is something that we've done before. If you've probably watched it 2 years ago, we did it over on YouTube. So the goal here is to use the parse to items from the parser and store them in memory in a way that we can easily compile the results, right? And so in the current version, I'm going to zoom in. When we execute the compiler, oh, so this is the code that we are compiling at the moment. It's a relatively it's a useless program, but it's a valid program, and the result is not readable. Like we we have all these sort of different symbols and different things that don't really need to be there. Like after I've parsed the program, I don't care if there's a symbol here. All I care about this line is that this is tval and this is 1. All I care about this one is that it's a return statement and there's an A. I don't care about the semicolon. I don't care about the keyword. That is after I've parsed the program, right? And so in today's stream, we're hopefully going to write this in a better way, right? And yeah, so that's my goal for today. And we can probably start by taking a look at how the current token system is working and what we need to keep the way it is and what we can change, right? I think that's a good start. So let's start by looking at the current tokens. So parser.h, let's see. So in the current system, we have these parse rules that they get the context, the source, and the position, and they produce a token star. And these tokens, let's go to this file, and these tokens essentially have a starting position, an end position, and a source, and the context is stored inside of them. They also have this operation between them and the another token, basically, right? Oh, no, sorry. This is the operation between them and an OS stream that is used for printing or debugging purposes, right? And we need to modify. Well, we need to provide more tokens so that we can escape this hell, right? And yeah, so we have things like a number token, a tuple token, and things like that, and we need to just get on with it and fix that. Right. So let's start. And the first thing that I'm going to fix is I think that it should be the return statement, right? Because in its current form, the return statement, return parser here. In its current form, the return statement is using the operator that we defined, which returns a tuple token, right? So if you go to the definition of this, can you go to the definition? No. If we go to the definition, probably here somewhere, yeah, you can see that when we use this operation on a token and a parse root, the result is always a tuple token. And we want to extract the tuple token because we don't really need them. right? But before we do that, before we go that route, we need to implement another class here. Then we are going to call it parse result, right? So the parse result class is essentially a union of two. Well, it's not a union, but it has a token inside of it, but the token could be null. And why do I want to create a new type for it? Well, the reasoning here is that we might want to hang on a second. Right. We might want to perform some kind of operations that we might not be able to do on pointers, right? So in the current format, we are performing them on pointers, and like for example here, these are all pointers, so they should be token star. And the bad thing about this is memory management. So I have to manually manage the memory for this token, and if I have to remember to free it if I don't need it anymore, and I have to um, do these things, and I don't really want to do them. So what I'm going to do is I'm going to create a class called parse result that has a deconstructor, and these are public. And it also has a constructor like this, right? And I'm just going to say that you will set the value of token whenever you are in, when we are calling parse result, we want to just set the token value, and then we want to deconstruct it. I guess I can write it in the parser file. Then we are going to deconstruct it. You are just going to do this. So if you have a token, leave it. Right. And it says token is abstract but has a non-neutral deconstructor. That's fine. We are going to provide it with a token like so. And since this is a virtual function, we are going to say that it is 0 by default. And this is going to produce like a bunch of compiler, or I'm sure of it, but this is something that we have to do. Right. And the next thing that I want to do is in the parser.h, instead of returning a token here, in the scheme function, I'm going to return a parse result, both for the scheme and the parse function. Right? Okay. And this is going to produce like a million compiler error, and we are going to go through them one by one and change them from token star to parse rule, right? Because that's fun. Right, so starting from the keyword parser, it says that this should not return the tokens. Oh, actually, I have to remove the pointer as well. Right, so now I'm going to record a macro, change f star, and then replace that with parse result, and then stop macro. Right, so that's fixed. Next, we have ID parser. So at q, right? Yes. Next, we have sign parser. So we just have to do that, and that's not going to take that much. At q, right? What else? We also have the compile again. Assign parser still has something else, I guess. Oh, we have to change the C++ file as well, so we do that. And okay, so the next error that we are fixing is that it says I don't know how to perform this operation between a parse result and a parse rule. So we can fix that. We have to define a new operation. So similar to what we had earlier, we just say that, okay, this is a parse result, and you get a parse result as input, right? Okay. Conflicting return type. Okay. And yeah, this is going to be what we have to do. So we just are changing that. And this is a mindless task, so let's chat. How are you guys doing? Is everything all right with you guys? What's happening? Value parser. And then, you know what? I can do this probably. Oh. So we fix assign parser. We have to fix the binary operator parser, like that, like that, and that's it. We have to fix this one. I'm going to close this windows. Okay, and like so, and like so. We have to fix this one. Well, yeah, here and here. We have to fix this one. Right. So while I do that, let's talk about the Roomy programming language. So I'm not sure how long you guys have been um, aware of Roomy and what I've been doing, but so um, the idea of Roomy is to create a programming language that is, uh, you know, that allows you to do things like this in an easier way. So, I'm just going around and changing a type to another one, and that's a very repetitive process. And this isn't something that a programmer should spend their time doing. Programmers should solve problems. You shouldn't really waste your time on things like this. But we have to do it because you know the current toolings that we use doesn't allow us to quickly change things like this, right? And the idea behind Roomy is that Roomy is going to provide you tools to do things like this much, much faster, right? Right. So this one, okay, and we have to change. We already changed this one. The if parser, we changed this one. You also have to change it from here, and we can start here. Right. We already changed this file. Next, that's fine. This one, like so, and like that. Right. So just going to keep doing this for 10 more files, I think, and that should be it. Token star. Type parser. And it's a good idea that we are doing it now because, I don't really want to do it after we have 10 more items, right? Right. And then that. And then we also have to go back and fix the if statements because we were relying on pointer arithmetics for them. So we just have to probably change maybe 5 or 6 lines of code after this one. And then the parser should work as is. And then we can start doing other things. Here, token. And symbols, that's fine. Token, I think that's, no. I have to change parse. Oh no, that is fine, right? That's the only exception that is fine, right? That, and then that, I think. Value parser, there we go. And the header file of value parser, that's fine. Variable value parser, like so. And then we only have 2 more to go, and then we are done with this refactoring. Okay. While parser, and this is the last one, right? Yes. Okay, so does it compile? No. So cannot convert parse result to token start. That's a good thing, probably. So what line is this? It's line 10. Right. So in your scheme, what is PS? It's a parse state. Right. So we can change the parse state. So you have binary token there. Okay, I see that. So here we have to say dot token, and that should fix that. Could not convert temp from parse result to boolean. Right. So whenever you have a if statement like this, we just have to add a dot token afterwards. Oh, and a dot token here, and a dot token here, and a dot token here, and a dot token here. Right. Any other errors? We have one in define parser. Again, we have an if operator, so we add a dot token and dot token again, and this one should have a dot token as well. Right. Is there a way to override that the result of an if for a class? Can we need to search it? So C++ override if. Right. You can do that by defining the bool operator. That is interesting. Operator bool. Okay, so I'm just going to define that. That's easier than doing it like this. So I'm going to revert the tokens, and I'm going to revert the tokens here as well. We are going to go in our token file and define. So I closed this thing, didn't I? Yeah. And we are going to define an explicit function, an explicit operator called bool. Okay, so operator bool const, and we probably have to define it somewhere. I'm going to define it in a parser file for now. So parse result bool return this dot token. Operator. Is that okay? No. Wait. How do I write this? Right. So I think we have to do it. Operator bool C++ implementation. Let's look at here and then bool. So right, you know what? I'm just going to declare it here. So it is an easy declaration. So you just have to return this.token. Right. So it is true if you have a token. It is false if you don't have any token. That's that. Yeah. And we don't need to go through and rewrite all of the things that we had there because we had a lot of if statements on the pointer, and this one handles most of them, or I think all of them even. Yeah. So cannot convert parse result to token star in line 144. Right. So this one we have to add a token there, and here we have to add another token. Right? And another, or we can actually call that a parse result and another pointer, and call this a parse result. This one should be a parse result as well, and this one too. And probably this one too, yeah. And just change it to auto. And this one to auto as well. And this one to auto as well. Right, and then we have to change the parser class. Parser class has a bunch of functions that need to be changed to parse results. I'm going to just do this. And then we are going to format these lines. There we go. That should fix it. Right, so that was a relatively easy refactoring, but I want to, do it much in an easier way. Oh, there's a typo here. It should be auto ends, not like that. Right. Ember parse.no invalid conversion from int to token star. Why would you want to convert to token star? Line 125, that's this one. So Why do you think that that's an integer? R is a parse rule, and parse rules they return a parse result, not an integer. Oh, because I've assigned it to 0. Okay, I see. I see. Yeah. So it has to be parse result ends like that, and we have to. I wanted to be clever there, but apparently I was being naive. Okay, let's see. No matching option parse result. Oh, right. You can't have an empty parse result. That we can fix. So parse result, we have to define something like this, and then say your token is 0. Okay. And that should be it, actually. So yeah. So now instead of returning a pointer, we are returning a parse result, and then we can utilize that to further optimize our parser. But first, we are going to try to rewrite the AST. No declaration, right. Line 180. Oh, of course. Of course. Parse statement. Why? Yeah, that should be fine. Oh, right. So it should be parse result here, and cannot convert parse result in line 198. So why would you want to have that? Right. So I think we don't need to have this operator anymore. I think that's obsolete because we have the new one. Or do you still need that? Hang on a second. So the result of a parse result and another parse result. Right. So we have to change this operation. So instead of having a token star, this operator, a parse rule resulting in a token star, we have to have a parse result. This operator, a parse rule should produce another parse result. And I'm going to delete that one and come here. Wait. So how do we define it? So if t is not viable, you just return it. Can we do that? Oh, that's a point. It's not a point. So if t is not doesn't have a value, we just return it. And otherwise, so we have to add a dot token here, I think, and a dot token here, and a dot token here. Right. And this doesn't create a token star, it creates a parse result. And this one, we just wrap it in a parse result. Well, I'm just lazy. I don't want to solve this in a correct way, so I'm going to do this. Oh, wait, that was fine. This should be dot token, and this should be dot token. Right. Is that okay? It is. Okay. So we fixed our operator. So now we have I think we aren't working with pointers anymore. Okay, again. No declaration matches token star parse rule. Right, so this isn't token star, it is a parse result. And yeah, you just do the same thing. You just have to change the return type. One last error, cannot convert parse result to token star. Okay, so, and this is just a debug statement that we have. So T is a token star, and we just change that to a parse result. And then we have to implement a print function for them. And let's just do that. So that's the last thing that we need to do. So we need to have an O stream defined on them, and the way we do it is by going to Parser file again, and we say that this, to print this, return OS, whatever that is, and token. And return the token that we have. Right? I think so. I think that's correct. So yeah, and that's his only for debug purposes. So if there was a problem, we can fix that. That's not a real problem. Right. Let's see what happens. And okay. Undefined reference to, okay, so we have to define the deconstructors for all of our tokens. How many are there? So we have ID token and tuple token. That's not that many. Okay. Let's start with the ID token. So you also have a virtual deconstructor, like so. And ID parser, we define your deconstructor. For now, I don't think we have to delete anything. The string value would be deallocated. That's fine. These are integers. We don't have to deallocate the source or the context. So that's fine. It's just an empty statement. The other one was tuple token. Tuple, that's depending parser. Yeah. Okay, we even have the deconstructor here, but we haven't wrote it yet. So we are going to define tuple token deconstructor. So what do we need to do here? For the tuple token, we have two individual tokens that we need to delete, probably. So delete T1 and delete T2. Redefinition of tuple token. Really? Yeah, that is a redefinition. Okay, just maybe virtualize it. But so we have to keep in mind that this could produce errors because we are deleting things that we are not sure we don't need anymore. We might still need to use T1 and T2 somewhere else in our process. So like I might be extracting T1, and then when I delete it here, that other T1 is going to be deleted. So we just have to make sure that this doesn't happen. Right. And let's actually define the token one as well. So I'm just going to token, just don't do anything. Right? Is that fine? 47, 44, 72, 75, and done. Does it work though? Segment fault. Okay. So again, this segmentation fault could be the result of us deleting things that we shouldn't be deleting. And I'm going to check and see why that is happening. Let's run valgrind. And it is telling us that, oh boy, invalid read of size 4 in the operator for parse results. I wish this was a debug build. Can I do a debug build in CMake? How do we make a debug build? Okay. Does anyone know how can I easily make a debug build? I mean, I can add flags. I only need the G flag, right? I don't need to. Hello, I'm here. So this is an English only chat. I'd appreciate if you would talk or chat in English. But hi. Okay, so CMake custom compiler flags and right. Set CXX flags, and then we are just going to add -g. Right, I'm going to do that in the CMake file here. So set CMake. Thank you. I mean, I do appreciate it. CMake CXX flags, and we need to keep the current flags, right? So CMake CXX flags, but we want to add -g. I think that's enough, right? And let's compile it again. Oh, did you really compile it? Compile everything? I don't think so. I'm going to remove the build folder and have it generate everything again and compile everything again. Oh, build is not a directory, is it not? Really? Okay, what if I remove the bin folder as well? Huh. Oh, we have to probably do this operator from here. Oh, wait a second. This is the wrong file. Yeah, this is the wrong file. This is a completely different thing. Is this so? What project is this? Yeah, this is the wrong project. Okay, that's why. Yeah. Okay. Do that and then build everything again for us. I had another CMake file open in Emacs, I think, and it was building that one instead. Right. So this should give us a debug build, and the good thing about debug builds is that when we run it with tools like Valgrind, you can see the line number in the logs here. Right. So let's run it again. Right, you see we have the line numbers here. Right, so the problem starts when we have an invalid read of size 4 in parse CPP line 198. Let's go there. Parser CPP line 198. So probably, if I had to guess, either T isn't a valid parse result, but that would have been catch here, or T has been deleted. So let's see who called it. So it was called by the function type parser on line 19. So we have to go there. Function type parser.cpp line 19. Right. This seems okay. Right? Yeah. I think this is okay. Then that's a parse rule. So I think that's fine. So you know what we can should probably print it here and see what's happening. So we can print T and then do an endl, right? See, okay. Yeah, it is printing the memory address for some reason, and so the reason is that this one, of course, that we have to add a star there. Okay, let's rebuild that again, and we run that again. Okay. Yeah, right. So it prints as the A, and then it produces a segment fault again, because I think the reason is that there is no token, so it can do it. That's all, right? Yeah, there is no token, and therefore it cannot call describe on it. Right. So for some reason, oh, I know why. Oh, I know what's happening. So here we create a new tuple token regardless of the result. Oh no, we don't do that. So we are. I really hate this types of problem. I don't know what to do here. Let's just start by the easiest thing to do would be to go to tuple token, the deconstructor of the tuple token, and just comment these out. As I said, I think this is causing the problem, right? And then no, that didn't solve it. Validity of size 8 here. What happens if I say if t.token? Does that solve it? It does not. On 198, so here we are reading something that doesn't exist. The only thing that doesn't exist here could be the token, right? Like I don't see anything else that could go wrong here. Okay, so maybe there's another delete somewhere else. So if it wasn't here, if this wasn't the problem, the ID parser could. That's fine. Where was it deleted? Let's see. Let's look at that. Block was allocated at symbol parser. Okay, where was it freed? Freed at the delete operator in symbol token. Right. Symbol parser.h. So it could be here actually. Deallocator. Symbol token. It doesn't have a. Oh, right. We don't have a deallocator here, right? And it's you don't want to do anything. Let's see if it's fine then. I should probably add a to-do statement. Right. See, the good thing about the Rust compiler is that it understands the problems of this type and doesn't let you shoot yourself in the foot, right? Because I'm doing some dangerous thing with pointers, and that's what causing all of these troubles from, right? Okay, so address is 12 bytes inside a block of size 40, freed here. I made sure that this isn't freed anymore. Oh, wait. So the parse result, right? Maybe the parse result is, yeah. See, maybe this is the deleted segment that is causing trouble. Maybe we shouldn't delete tokens. I mean, that was the whole point here, right? But maybe we shouldn't. Do you work now? Yeah, it does work. Okay. I'm going to add a to-do setting here again. So we're back to where we were at the beginning, but instead of using token stars, we are using parse result. And I know, like, it doesn't seem like that's doing much, especially given how well it isn't really working. But we can replace the pointers with smart pointers somewhere down the line, or we can write our own version of a smart pointers that does a little better. I don't know, and that way we don't shoot ourselves in the foot every time we work with them. But so the reason about why I wanted parse results to be there in the first place was that we could use them in memoization, right? So instead of in the current system, we are memoizing by looking at the what do you call it? We are only memoizing the expressions, the binary expression, I think, and we are doing that manually. So yeah, you see, we have uh, a state associated with the position, and we'll look at that state and see if we were trying to do a binary operator on there or not. And we can do this for not. We should do this for every other type by performing the same thing here in the parse function, right? Even here, I have said that we should memorize it. And memorization isn't necessary except for the expressions. It isn't necessary, but it will allow us to run a lot faster. So it will go from it will go from an exponential time to a linear time, and it will only cost us a few more, maybe a few kilobytes of memory. Not even a kilobyte, less than that. Well, for a large code base, probably a kilobyte, but And yeah, so that's something that we can do in the long run, right? So what I wanted to do in the first place, I want to clean this up. And let's just start by cleaning the first one, which is an assignment. So it is being displayed like this because we are keeping all of the symbols. You see this symbol, this one, this one. We're storing all of them, and I don't really like that. So I'm going to change this, and we are going to go to the assign parser, and we are going to split our screen and go to the other assign parser as well and see what we have here and what we can do. So yeah, you can see this separator, although really useful in parsing, has certain limitations. And the limitation is that it's, well, oh wait, that's a different one. We have to go to the define parser, right? We can come back and look at the assign parser sometime later, right? Yeah, so we can see it is extremely useful the way we handle the define parser, but the problem is that um, the result is a tuple of a tuple of a tuple of a tuple, right? And I don't want that. I want to have a defined token, and we even have defined tokens here. I'm just going to modify it a little bit. So we have a so the defined token should have an std string ID. It should also have a token star type and a token star value, and we are going to define them like so. So ID will fill ID, and then type will fill in type, and then value will fill in value, and we are going to define those here. So std string ID, token star type, and star value, right? And instead of returning a tuple of a tuple of a tuple of a tuple, we are going to return our defined token, right? I think that's a reasonable thing to do. So we are performing two return statements. One of them is here, and the other one is at the end. Let's move that up there just for aesthetics. Right, so so let's look at what we're doing here. So we are parsing the ID, and then we are parsing a column, right? And then we are parsing a type, but that is completely optional. So we might discard it. The type might not be available, in which case we will go back to the column and then we will look for value, right? So I'm going to right. So we are going to define a token star type and a star value, and we are going to assign both of them to 0 at first. And here, this is going to be auto. This is going to be auto ants equals that, and then return ants for now. Right. So we should create. Oh, semicolon. We should create a new. Basically, we should create new parse result. No, return parse result. No need to add a new statement there because that's not the pointer. And inside that, we are going to say new define token. And I forgot to do this. Right. So the define token should get the ID, and you get the ID from ID dot Hang on a second. Just return early if there is no ID there. Right, so we will return early if there is no ID there. Otherwise, we will create a std string pointer, and it's going to be SID. And how are we going to capture that? Well, we are going to say this is an ID token, a star. What is the ID token? It's stored in here. And the good thing about ID tokens is that they have their ID somewhere. And we want to get the pointer to that. Right? And I'm getting the pointer because I don't want to spend a lot of memory by copying things here. Right. And here, I'm going to pass the ID as a first argument. And then we have the type, the value, CCS, and for the position, I'm going to say ans.token.spose and ans.token.epose. Like so. The only problem is this one for some reason. Oh, because it should be SID, not ID. Right, so let's see what happens. So if we omit the type, which we usually do, we want to do this. And the only thing that we have to check is we have to check to see if we have an ans. Otherwise, we should just return it like that. So if you have a v here, we should return it like this. Otherwise, do all of this, and instead of relying on the ans, you should rely on v. Right. The next thing that I think is important is to assign the type and the value. So the type here would be t. Okay, so if there is a type would be t. So this is a tuple token. No, this is a parse result. So t.token, and we know this is a tuple token, and this would be t2. Oh, like this. The t2 would be the right one, which is the type here. Right. And here, value would be the same thing, but instead of relying on t, we would rely on v. v.token. Right. So this one. I think that's correct. Let's see what's happened. So we compile that. We run this again, and yes, so it replaced all of them with the define. So yeah, so it parsed correctly. We just have to display it correctly too. So how do we want to define it? I like to display the name here. So define ID here, probably. Add. And then optionally, if there is a type, add it here, I guess. Otherwise, don't add anything for the type. Type that describe. Like that, right. So add the type description in the parentheses, and then if there is a value, add it like so, and then class value that describe, otherwise empty string. And again, this should be the reference operator. Right. So now, right. So we define a. The type is some weird thing. Are you calling your lecture a parser, or do you have a lecture and this is the next step to paste it? So in the previous version, lecture and parser were separated. In this one, they are stored together, right? So let me show you. So in the previous version, and you can see it's called the old branch. We had a lecture and we were using flex, and we had a parser somewhere here, and we were using Bison to parse it, right? And Lexer would convert stuff to token streams, and Parser would consume tokens to the AST syntax tree. But we are moving from that and converting to a peg parser. And so in peg parsers, you can still use the Lexer and tokens consecutively. But since I want to give the user the option to define their own parse rules, I'm going to put them together in one class and only create new rules for the treat lexing essentially as part of the parsing. Right? Does that make sense? I hope so. If not, I'd be happy to show you the old code or the one that since this is the fourth version of the compiler, so we are doing different things. Thank you, Crazy Phantom, for following me. Right. Yeah. Okay. I'm glad that you're asking question. That's really valuable. And Crazy Phantom, thank you for coming here. Just a quick thing. This is an English only chat, so please keep it like that. We can talk in Persian in Twitter or Telegram or somewhere else. I'm writing my own compiler as well, so just interested in different perspective. Yeah. So if you're writing your own compiler, I first of all check Roomy out. Here's the compiler file. It's mcsh Roomy. I'm going to paste the link in chat. Oh, no worry about it. No worries. I'm just saying what we're doing here. Right. So yeah. So Roomy has 2 branches, I think, or 3 branches. Wow. So the one you see on the screen is a bootstrapped version because we did that, right? So this is the compiler code written in Roomy, and it's only 4,000 lines or something like that. And in the old branch, you can see the C++ version, right? So there's a parser and lexer and everything in between. So do check that out, and feel free to ask any question that you might have. We also have a language documentation here. I don't know what the docs. Yeah. We also have the language documentations here. Check that out as well. It would be fun to see others, collaborating here and there. Right. Okay, let's get back to it. So here it is correctly identifying the symbol, which is A. The type is, well, I mean, the type is correct. The type is this. I'm going to change the example that we are parsing. So instead of parsing that, let's parse this one. Oh well. You know what? First this one, and I'm going to comment this out. Right. So it's a defined statement a and then one, which is correct. And then after one, we see the semicolon version. So this is the value. The type is omitted because we didn't supply it with a type. And semicolon is there. So the idea here works. You just have to apply it to different files here and there. So what's your compiler? What are you working on, Nixify Dev? I'm interested in seeing other projects like this. I've been working on Roomy for 2 years now, maybe more. The project started in 2019, so yeah, 2 years. And well, I started showing the project to the public in 2019. I was working on it for a long time before that. But the goal behind Roomy is to have a language that allows the developers to do what they want to do. And we have a metaprogramming language, which is exactly the same as our regular language, that's the main selling point for me. But others see different things in the project. Right. So let's go and write the change the number parser, I guess. Right. So in the and I think I know what's happening there. So the parser, if you want to omit the semicolons all at once, the main thing responsible for that is here. So we have different top level parsing are done in the parser itself. So we have parse statement, we have parse value, we have parse expression, blah blah blah, right? And we have something called a value parser, I think. Value parser, right? So value parser either parses values directly or parses an expression and then adds semicolon to them. So if you're parsing values directly, that's awesome. That's all you need to do. But if you are parsing an expression and adding semicolon at the end, that's problematic, right? And the problem is that, well, you add the semicolon here, right? And we don't want to see that. So let's work on that. Value parser.h. So how can we change it? What we want to do? I'm working on a highly performant scripting language that is parallel both at compile time but also at runtime. It's going to be used for highly performant and cutting edge MMO engine. Oh, that's nice. So you're doing that for game development, right? That's nice. So what? Do you have a link or something? Maybe you can share it with us. And by the way, does the chat appear on the screen? I configured it to do so, but I'm not sure if it is doing it. Let's see. Apparently it does. Yeah, okay. So that's good. Right. Okay. So I see two ways of handling this one. So first, we can create a new token type for parsed values and go from there, or we can just change the end position of this one. And I think the second one is more interesting, so I'm just gonna do that. So if there is no A, just return whatever you have there. But if there is an A, The current compiler directive is old and probably isn't a good representation of what they can do. I forgot to push them and so forth because it's has to work. Sure. I'm going to nay. Okay. Let's see. So what am I looking at? Let's go to the source. Any samples? Do you know any good source for learning about compiler and compiler design or something like that? Here's a fun some. Since I know you're a Persian speaker, I did a couple of videos on my YouTube channel a while ago, I think. You can check them out. Send me a message on Twitter and I can send you the link. Right. But if you're interested, aside from that, you can also look at courses. There are many different courses available. I think LLVM has a very good um, tutorial as well on implementation, not design, I think. But you can read about programming languages. There are books and courses about that. The design philosophy. Let me look at that. We are not stuck in the way C does things. Performance and mental memory management is important. Okay. The same code should be able to compile to machine code and be run during compiling and use. Okay, that makes sense. Bytecode running in a virtual machine. Okay. So I respect your definition, but I don't like to run codes in virtual machine. Generally, so if you're using LLVM, you can. LLVM has a functionality that allows you to run things in the compile time using the JIS compiler, and it doesn't run on a virtual machine. It runs directly on your machine, which is good. Okay. So that's constant variable a of type in. Okay. Function. Right. Okay, that's interesting to see. I'm looking forward to see how this turns out. Yeah, Jonathan Blow working on J has a lot of good videos, but the thing is, he is focused on designing a compiler for game development, and not everyone does a game. Not everyone is doing game development, right? So personally, I like to do string manipulation a lot because I used to work on chatbots, and the idea behind Roomy was to allow you to do so, right? Yeah, he doesn't teach very well. He streams a lot too. You can see his Twitch channel. I think he's on vacation now, but you know. Oh, running in the Webcam VM. Okay, I see what you do there. So, let me showcase something here. So, mhm. So what we have here, I think I'm going to open it here. This one. So this is the some old code, and no, the third test, right? So in Roomy, you have the compile directive, and what anything that is any function that has compiled before it, it's going to run in compile time. So, and you get the compile context as an input, so you can do whatever you want. So, for example, here I'm calling the exit function with a value of 100. Just as a demonstration. You can even do things like this. So you can define a new compile directive and then call that. This is going to add an ID field to the struct, and you can see that you have an ID here. And you can even perform some tests. So, for example, we do a test, we expect the remainder of 8, by 4 to be 0. If it's not 0, we are going to produce an error. Right? You can do all sorts of different things here with the compile directives. And the way we implement them is by, I think it's statement and then compile directive, right? Yeah. So the way we implement them is by instanting the LLVM execution engine, and we would we would compile the function, and then we would get the function address and then just call it directly, right? And this works. There are different branches for different types of operations, and you're checking everything. And yeah, so you can do that. Right. Well, yeah, your mileage may vary. It's all dependent on how you're going to do this. Thank you. I really like that as well. That was some suggestion from someone. We were designing we were writing the code together, and someone suggested to use the at compile instead of doing other things. So that's similar to Java's. I don't know what they call it, but Java has something similar to that, and Python has something similar to that as well. So yeah, it's a familiar syntax. All right, so let's get back to this one. So it does. Yeah, you can do a lot of things with the directives. Right. So we get the parse expression added with a semicolon, and if there was no such thing, we just return an error. If there was such a thing, we are going to create a parse result. So I'm not going to create a parse result. I'm going to modify. Well, let's see. So parse results out would be a parse result, and I'm going to capture the first token. So the first token would be a.token, and we know that this is a tuple, so we can do it like this: tuple token star, and then capture the first one like so, and then we can return parse result f. Yeah, and we are not going to get a compiler because we are checking to see if tuple token exists, and we just have to change the end position of this. So f dot end position would be a dot token end position. I think it's always important to measure your options based on your use case. There's a lot of right and wrong ways of doing things. Yeah, I agree with that statement. So for me, it makes sense to use a LLVM because I'm interested in creating bytecode in the end, but I can see why someone wouldn't want to use that. Right. So doing that, the semicolon went away, right? So we had the semicolon here and it just went away. I think the same thing happened for, let's see, T shouldn't have a semicolon at the end too. So T doesn't have a semicolon at the end. And that's exactly what I wanted to do, right? Okay. So what else is going on? I think you saw another link that I forgot to open. Let's see. Let's look at that. Oh, so you were scripting for World of Warcraft. Chocolate. Okay. So what's happening here? Could you explain? Better we'd like to have a separate output path for all game machine code and possibly our manual return ASM at some point would be fun, but mostly external. Yeah, right. So I'm going to get back to this one. I'm showing a bit of our UI settings and our engineering tab. Okay, I see that. Okay, that's interesting to see. Disable the login screen and show a bit of the world, change the time of day, and showcase the inspector interface. Interesting. Yeah. Okay, so that was audio. Okay. Right. Okay, so we have done a lot today, but not as much as I would like to do. So let's keep going here. I'm going to. Wow, that's a lot of files. So since this works at the current step, I'm going to commit this so that I don't lose any progress accidentally. And what did we do? So we added parse results, and we made modified define to be less verbose. Modified define, and what was the other one? We also modified the value parser, right? Yeah, define and value parser to be less verbose, right? So next step, we are going to make the function call less verbose because that's the next item on my screen. Okay, let's do that. Function call. So function calls have to, well, we can't do the same thing we did earlier because function calls are really complex structures. They have an ID for sure, and they have an arbitrary amounts of uh, arguments, right? So this is how I'm going to do. I'm going to create a fcall token, and I disable the login string and show a bit of the world, change the time of day, and showcase the inspector interface. Nice. Yeah, I did see what you did there. That was interesting. I'm looking forward to see uh, how you go with your language. You ping me whenever you have a working example that I can try. Oh, we wrote a tool to extract World of Warcraft's assets into our own format, although it does require a version of the game owned by yourself. Yeah, yeah, it does. Okay. Thank you for following me. I do appreciate it. Okay, so going to keep working on this, and then um, I mean, I really like learning about different programming languages out there. So what I'm doing, I need to have some reference so that I don't make mistakes. Let's look at a symbol parser, I guess. We want to use NAA in our gameplay scripting language, hoping to power everything through the scripting language instead of C++. Okay. Oh, that makes a lot of sense. Right, so here we have the ID or the function. I don't know how to. I guess we can. Let's go with the ID for now. So you have the ID. Then we also need to have a vector. It's the vector of tokens for the eggs. And these should all be public. We need a constructor and a deconstructor. So, oh, we don't need a. I don't think we need a deconstructor. The default deconstructor works here, right? But I'm just going to write it just in case we want to come back later and modify this behavior. There's also why it has to be really, really fast and parallelizable, which is also why NA is baseline pure, aka no global states allowed. Okay. So I don't know, like in a scripted language that doesn't have a global variable seems hard to manage. I don't know how you're going to handle that. But that'd be interesting to see in seeing how you're going to move forward. I wouldn't. I don't think I would ever. Well, yeah, I don't think I would do such something like that. But it's different people have different ways of. Like I don't have an idea of how it would work, right? Because in my mind, scripting is you have a state machine that you're constantly moving around, like you're modifying a state machine, and if there's no global state, there is no state machine, and you have to pass the state machine, and that would be hard to write in a scripting language. But again, I haven't seen much of the code to see since you said that the code, uh, the repository was old, so I have to see the new code to see how you're going to handle that. Okay, so we also have our own describe function here. And again, I'm just adding the to do here to do that later on. So what else do we have? We have a constructor, so f call token, and the constructor should get the ID. We might want to get the ags as well, or well, let's not do it. So we get the compile context, we get the source, we get the starting position and ending position, right? So let's implement all of that. So the fcall token. I'm just going to copy this, and then fcall token like so. Right. So the main problem with Go is that you have to undefined behavior if the same script isn't executed with some concept. This isn't guaranteed for us, so the most of bad behavior. The idea is that you have the main function which registers any events you meet, and an integer will call it. Okay, right. And you probably pass the nature memory. It's C++ possibility to and from the extremely cheap fast. Okay, so you may want to look at the Lua compiler because they essentially do something very similar. I mean, there are differences, but it's essentially the same thing. Right. And can I copy this one? I probably can, right? Yep. Just format it like so, and we are good to go. You want to use Lua, but they don't allow pure state besides adding runtime checks. Yeah, so you can either modify the Lua compiler. I think the compiler is extremely lightweight. That's why we went on this adventure. I must say, I have a newfound respect for compiler programs. Yeah, they do a lot of work. You can also use GUI, I think, the Lisp compiler, but that's if you want to use Lisp, which not many people want to use. So I don't know. Right, I should be here. So the description for call token should return the ID. Well, it should say this fcall and ID, and then closing statement like that. Oh, it should be call token. Oh, no, it should be describe. I love the level and I love optimization. I love running the compiler assessment. The first version of the compiler could compile 5 million of code, but okay, that's nice. Speed is really important, but don't spend a lot of time optimizing things. I usually try to have something that works first, and and then I try to refactor my code base every now and then to have a better working version. Right. I'm going to create something like that here, and then just something like this. Use args.size. So you add args would be args of i.disk, and like so. And if I is not len -1, oh wait, this shouldn't be args. This should be args s, and args a string, and this should be args s as well. This should be args s. So if this isn't the last one, add a virgule and a space. Otherwise, just add the space. You can even, yeah. So that is, of course, if you have a len. Otherwise, do something else. So if there is no len there, we are going to say that well, you will initialize args as an empty string. But if there is a len, so we will add open parentheses here, and then we will close it here. Semicolon. Compile. I learned that is why this is where focusing on functionality and performance. Already know the performance is quite good, so I'll focus on optimization. Primarily in network programming, so optimization is often something I find myself doing early, but that doesn't work for all aspects of code. Yeah, it doesn't work, especially not if you're doing things like this. Right. So, oh, I forgot to change the scheme. So this compiled. So I'm happy with that. Now we just have to come here and do magic. So L2 ends is that. So if there's no ends, then just return it. Otherwise, you have to create a parse result with the ends. Well, So I'm going to create a fcall token star fct, and that's going to be new fcall token, and we're going to do it right here. So if there's an ID, if there's no ID, return early. If there is an ID, so it should be well. So the first argument should be the string. Let's say it's in SID. The second argument is CC. There you go. S suppose, which is id.token suppose, and the epos, which is id.token epos. You have to update the epos at the end, but otherwise that's good to go. So fct.ePosition is ends.token ePosition. Right. And we have to deal with SID. So city string SID is again. So let's go into the rabbit hole. We know that we have a tuple token. Tuple token in ID.token. And we want the first one. And we know that this is a ID token, right? And we know ID tokens have ID. And this should be a pointer to this one. Right, so let's see how it does. Fcall F, that's perfect. I have to go. Okay, that's fine. If you're streaming, I'll join again. I'm looking forward to you coming back. Right, so we parse the function call here. I'm looking at this line and this line. So we parse the first function call, but we're not parsing the arguments. So let's focus on the arguments for a second. So these are the arguments. I guess the EP is the argument. So what we are going to do is this. We are going to say fct args dot push underline back temp, which is a tuple token star temp dot token, and then capture the right one. Right? Yes. So we capture the right token and we add it to our argument parser. So this line should be, oh, damn it. So why are you not being added there? Oh, the first, yeah, okay. So the first one is handled here, and the first one is not T2, it is T1, and if T, do this one. And it's not temp. Oh, wait. Wait. So the first one is here. And so we have an ID and then an expression. So it should be T2 again, right? Yeah. Let's see. No? Why not? So we are here. We have parsed We're looking for an expression parser. So the expression parser should see that we are calling another function inside here, right? It could be maybe the printing function is having a trouble. So no, that seems fine. Oh yeah, wow, wow. I forgot to add it here. So okay, don't tell anyone. I made that mistake. Let's see. Yeah, so we have a function called f. It is doing something else inside of it. We don't know. We don't want to know. Right. What if we have it like this? So what if we come here and in our function call and give it another argument like that? Yeah. So it's 0 and then the other function call. Right. So it's weird for me to me that the first function call is being parsed correctly, but the second one isn't. Like this isn't what we signed up for, right? So why is that happening? Oh, because we have another return statement here. Okay, yeah, I see that. We have another return statement, so we should be doing it like this, and this should be called auto ends, and then we want to do exactly the same thing. So like that. Right. File, compiled, and let's go here and run it again. Right, so we have a call that has a 0 argument, and then another call that doesn't have any argument at all, which is exactly what we're after. I like that. This is turning out to be good. So let's comment that and say that this is a call token. Okay. Next, we need to go to function definitions, and oh my god, that's going to be hard. I really don't want to get to the function definitions, but we have to do it, right? Maybe we can take a break. So what else is going on? People, feel free to chat. Send me messages here. What are you guys working on? What are you guys interested in seeing? Tell me. Nothing? Okay. Right. So we did add the function call token. Now we have to go to do the function definition, I guess. And that's the hard one. That's the hardest one. Function parser. So function parser is the hardest one because there are so many different things involved, right? You can see like this is the code. Just imagine how many different elements we have to handle, right? Oh, we do have a function token, which is nice. So the function token that we have has just that's a basic token thingy. So we can probably reuse that. But so what you're interested in seeing is that we want to have an ID, of course. We want to have a vector of tokens called statements, and we want to have a vector of tokens for arguments, right? Yeah. So here I'm going to create a well. So do we have the ID here? No, we don't have the ID here. Right. because at this point all of the functions are the ID is handled elsewhere, so we can't really work with that. But what we can do is we can look at the statement and the arguments, right? Because we start our operation by looking at the open parentheses. So we don't have the ID. The ID is parsed elsewhere. Yeah, in this function operation, this is what we are parsing. So it's a function body parser. Maybe we can function body token. Maybe we can change the name. And here it should be function body token and function body token and function body token. Right. So args and statements, we can do that probably. So let's create a so the args are being handled there. And okay, so I'm going to create a function body token star fbt, and we are going to instantiate it ccs pose and then pose again, and we are going to update the epose in the end, and this would be star. Right. So yeah, and so when we are returning 0, here you should delete fbt, and here you should, well, you should have an ends here, and then if ends, return ends, I guess, and then delete ends. No, delete. Oh, sorry. If the ends is not defined, we are going to return it as is, and then we are going to say delete fbt. Otherwise, return a parse result with fbt, and just update fbt epose with ends.token epose. Right. So now all we have to do is add each of the arguments and each of the statements to our function. So compiling that, our compile log should become much smaller. Right? Yeah, it just says function because we are not displaying anything. Right? So okay. So I'm going to say that cd string statement s and cd string args s, like that. Let's have this one open just for reference. Function parser. Yeah. So the function should display the args here, and then it should display the statements here. Statement what? Okay, this is string. This is a statements a string, right? Like that. So how do we want to print the args? Well, if args dot size. So if you're not empty, we want to, well, int len. I like to do it like this. I don't know why. Right. So we get the length, and then if it's not empty, we are going to start by saying you have an open parenthesis, and then like so. So you add what do you add? You add the act I describe, and if it's the last one, you add the closing parentheses. Well, yeah. Otherwise, you add a comma and then a space. Okay. Yeah. So wait. Oh, right. It's not showing anything because we haven't added the ags, right? So I guess it's here. The effect, just fpt dot ags dot pushback ags. Hello, Mr. Edmix. Welcome to the stream. Please start token. How are you doing today? Right. That didn't work. Wait, what? I'm a bit tired. I'm fine, thank you. We've been making a lot of progress in the past 2 hours, and I think we are going to go for maybe another half an hour or so. But I'm starting to lose my voice, so we might stop earlier. We're working on our compiler. We are cleaning up the mess that is the AST at the moment. So we're going from this one to a cleaner version, and we've done quite a bit of progress at the moment. Right. So the main function has a lot of different arguments, and none of them are showing up. Why? Oh, I see why. Because I forgot to add a plus here. No, a plus here. What language are you compiling? We are compiling Roomy. We are compiling Roomy, and I'm going to drop some links for you in a second. So this is the design doc, and this is the compiler. So Roomy is a compiled language. Let me show you. It's a language that I've been working on for 2 or 3 years now. And well, I guess I could show the GitHub repository. That would be better. All right. So this is the Roomy language, and you can see there are 3 branches. So we have different. We've been re-implementing Roomy almost every 8 months or so. And so it's a really powerful language. At one point, we had a bootstrapped version. So this is the syntax of the language. So everything in the language is basically what we call the concept. So you have a name, you have an optional type, and then you have a value. No, don't worry about it. I like to talk about it. I'm really proud of the language design. We can keep going, right? So some things only have types. So for example, an struct is only a type. So we define it like this. You see, and so this is the code of the compiler that I'm showing you. Right. So the name is only an struct and it's only a type, so we don't add any value for it. Same thing for enums. We don't add any value for them. But a function definition, we don't need to specify the type because the compiler can look at the function and say, okay, I can see your type is debug, a pointer to debug info and to void. Right. And the same thing applies for other statements. So, for example, look at here. the compiler can look at the type and say, okay, this is an expression probably, so I'm fine. And then we say that, okay, this is also an expression. So both of these are different ways of saying what you have. And the good thing about Roomy, if you go to the old branch and look at the test, if you go to the old branch and look at the tests, so we have a lot of different features. But the most important one is this one. So we have a compile directive. So if you have compile before a function, it is going to be run in compile time. And it is not a virtual machine that's running it. It is going to compile your code to bytecode and then dynamically load it and then run it. And you can do some really cool stuff there. So for example, in here, in this function, I am testing to see if the reminder function is working correctly. And if it's not, I'm going to return return an error that is going to cause the compiler to stop execution. And if you return 1, it's going to print a warning message. If you return 0, it knows that everything was fine. So that's a basic usage of this feature. You can also modify the code. So look at this one, for example. So we have a compile directive that is going to add a field to an struct. So the struct here doesn't have an ID field. It only has an A field. And through this function, you're going to add an ID field from inside, right? So you get this one as a result. You have ID in your struct after running the add ID on your struct. So you can modify the code any way you want. You can change the order. You can optimize the code here. Not said, thank you. And yeah, this is a design document. You can feel free to look at that. I sent the link. And ask any question you have. I'd be happy to talk about it. And you're almost done, by the way, so you're not taking any time. I'd be more than happy to answer anything you have. Any question you have in mind. Right, so I'm going to do the same thing for the statements. Almost like Lisp macro. Exactly, Lisp reader macros was what I had in mind when I wanted to do this. But the problem with Lisp is that Lisp doesn't compile to bytecode, and so it's not optimized for a lot of different reasons. But I really like Lisp. I have a huge code base written in Lisp. I'm coding in Emacs right now, so you can see my appreciation for Lisp. Right. So the statements, I want to print the statements line by line. I think that's okay. Let's see. So, yeah, line by line should be fine. So, how are we going to do that? We are going to write a len, and then we are going to say, yeah, so we have to start. We can just start the loop, right? We don't need to do any start case or end case, just a normal function, normal print function, right? So we just do it like this: a statements s plus equal, let's start the new line, and then probably 2, 3 indentation, a dash, a space, and then the statement. So what's the statement? It's a statement I describe. That should be fine. And we also want to add the statement. So where are we parsing the statements? So that's the type. And then I think this is the statement parser, right? SP is the statement parser. So we can come here and say that fpt.statements, and this is really dirty code. I know that. We just want to get this done. Push that back, and let's just do temp. So tuple token. My internet keeps disconnecting. I'm sorry to hear that, crazy phantom. You can look at the video on demand later. You don't need to, or you can look at the source code later if you have a problem. Right. Right. So we have a tuple token, and we want to look at the second one. I should do like that. Right. Let's see. Right. So the main function. These are the args. They aren't cleaned at the moment. And these are the things that we have. So that's fine. I'm going to add the return type at the end too. So we should see the return type. Function parser.h return type. Oh, that's a function parser, man. That's the wrong thing. Right. So function parser, you need to capture the return type for me in a token. That is 0 by default. Right. Because not every function has a return type. The default return type is unit, but you don't have to specify that. Right, so where are we handling the return type? I think this is this one, right? RBSP, that's a symbol parser, that's not the return type. Return type, it's here, right? So if you had the return type, and otherwise you go back the parser, you revert the parser. So if you have the return type, fbt.return type would be, I prefer the element prefer, so I have a few. Sure. I'm sorry that you're going through this internet connection problem. Feel free to ask any question you have. Right. So our return type is this one, TP. So we have a tuple token stored in this one, and then T2. I also want to display it. So we have a std string RTS, which is empty by default. And if you have a return token, not like that. Come on. If we have a return token, RTS is going to be couple spaces, an arrow, and then RT describe, and then we will add RTS here. And a new line, I guess, so new line. That's better. Right, let's compile this. Yeah, so the return type for the main function is unit. That's awesome. This one doesn't have a, EMT doesn't have a return function, so that's that. This doesn't have a return function, so that's that. Yeah, so that's our function parser. That was surprisingly easier than what I had in mind. Add function. Function body token. Right, so looking at this mess, the next thing that we have to do probably is, well, we can clean this up, actually. We can probably clean this up by a lot. So let's do that. So the arguments, we are pushing everything here, but we are only interested in this one and this one. And we can do that via a define token. Can we not? We probably can. what's our define token like? I wrote it just now and I don't remember. So we have an ID type value. That's exactly what I want. So I'm going to say the string arguments ID, and I'm going to define this as a pointer just because. So arguments ID is the IP one, so 2 levels dip. Let's start with the type. So token star type is what? So we have a tuple token. I don't know what to name this one. TT. That's tuple token. Right. So args.token is a tuple token. We know that. How do we know that? Because we are using this operator. And that always returns a parse result with a tuple token inside. Right. So this is tt.t2, the second one, t2. The value is 0, so we can ignore that. And then this one, the string ID would be tt.t1. So the left-hand side, which is another tuple token itself. So let's convert that to a tuple token. I know this might look a little bit like, yeah. So this is again a T1 of that one would be here, and that's another tuple token. Oh my god. There should be a better. There's a better way of doing this. Now, what am I doing? Just delete this part, bring it here, and then do it like that, right? And then TIP, and then my string argument ID is TIP is only one tuple token, right? One tuple token, and then TIP, and then that's T2, right? Yeah. This should be the token. The pointer to this. So we want to do it like that. Oh, this should be the this is an ID parser. So ID token star. I swear I know what I'm doing. Okay, yeah. Right. Right. Let's see. Let me just stare at that for a moment. So TIP is this one. It's not null because args is not null, so that's fine. The token is a tuple token because we are using the operation here. The right-hand side of that is a ID token because IP is an ID parser, and that has an ID, which is a string. Yes? Okay, so that's fine. That is completely fine. Now we are going to pt args.push underline back new define token. Right. So ID would be star.aid. Token would be type. The value would be 0. CC is CC. Source is source. Position is aid.token expose and aid.token depose. And we have to include define parser for that. It's easy to do. Come on. Why is it trying to save it? Okay. I don't want to become famous. Thank you. And this spammer. Right. So AID. So what's the problem with that? That's not type. That's T. AID. It's not AID, is it? It's AGS, and that's AGS as well. And then this is an arrow. Right. That should have fixed it. So the arguments should be prettier now. Let's see. So main has an I of type int, has a J of type F32, has an A, which is a pointer. Right. We are not parsing pointers probably, so that's fine. And has a unit return type, and that's everything in between. Okay. I'm going to fix up. Okay. So next, we can work on the pointer thingy. I don't like that. So let's go to the pointer type parser. Okay. Pointer type. We can do this. So a class pointer type token is a public token. And I'm going to have a sip of water. Right. So, because I'm a cheater, I'm going to open my cheat sheet for another another token to see what I have to add here. So we need to have a constructor and a description function. Okay. So pointer type token. As a constructor, you need to have a token star in a type, the context, the source, the starting position, and ending position. You also need to override the describe function, like so. And so you have to also store the inner type. So I'm gonna do this. Is that it? I guess so. Right. So let's start by writing pointer type token. Pointer type token. And these are what we get. Copy and paste. And like so. Right. So you wanna set inner type here just because we can. And for the rest of them, because we can't, we are going to say list.cc is cc, list.s is s, list.position is position, and this.end position is end position. I think this is s pose, not pose. Yeah. So that's the thing. And for our description, I'm just going to add a star. So I'm just going to add star plus description of the inner type. Okay, so when you finish parsing, if there was no answer, return it. If there was an answer, return a parse result with a new pointer type token that has token star inner type, which is couple token star, and then ends, and then T1, right? Yes. And stop token, right? So the inner type is inner type, CC is CC, source is source, position is ends.token expose and ends.token epose. We have to have the starting position and end position so that we can memorize things, right? Let's see. We did all that so that when we run this, a pointer to a symbol? No, that's not correct. The second one. Save, compile, file, and run. Right. A star to string, which is correct. Right. So we have the define, we have, oh, we don't have the assign. Okay. We should work on the assignment as well. And we can do that after I take another sip. And then all that would be left would be if, while, and return. I think. Yes. That's good news. We got a lot done. We got a lot done today. Right. Oh, no, not like that. Like this, and open the the one that we were looking at just now. Right. So class assign token is a public token. So what do we have in assign token? We have an ID, std string ID, and we have a value, which is another token itself. Right, and then we need to have a constructor assign token. You get the ID and you get the value, and you get cc source star s. I probably should do something instead of writing all of this every damn time. Okay, and then we need to have our describing function that overrides in our semicolon, and then that's it. We need to have this open for emotional support. Right. I'm going to paste it and then just change the name. So pointer type token, no, it's assign token. We don't have in a type, we have value, and we also have an ID. So the string ID and a value, and then so ID and value. Right. So that's the assign parser. I think should be right. Yeah. Let's capture it. Return parse results. No. If there is no ends, return it. Otherwise, return parse result. New sign token. The ID is, wow, I have to capture the ID. Auto TID is this one. And you reuse that. Right. So the ID would be ID token star TID. Oh no. TID.id, right? That's our ID. I'm going to do. I can't read that. Is that correct? TID.token. The value is tuple token star and T2. This is the value, right? This is the equal sign. That's the value. So we capture that. Again, dot token, right? We have CCS, and the starting position would be ans.token.expose and ans.token.epose. Maybe we can bring those to new lines for aesthetics. Okay, what's your problem? Calling a private constructor. Oh, I forgot to declare these public. Okay. Yeah, and then a semicolon at the end, and compile, and the assignment should. Oh, we have a problem. Uh-oh. Uh-oh. Oh. Undefined reference to detail for assignment. Okay, so we need to have this. We forgot to write the description function. Okay. Assign token, describe. So how do we describe it? We return our ID. We add an equal. We add value dot value like that, and then describe. That's like that. Okay. Compile, run, and yeah, you see this line changed. Previously, it was like this. Now it's like a normal assignment. So that's defined. That's fine. That's fine. That's fine. Return a statement. Okay, let's do the return statement. This is getting really tiresome for me. In 2 hours and a half, maybe the return statement is going to be the last one, and we can work on the if and while in another stream. Hi Fatimu, welcome. Sorry, I didn't see your chat message. It was. How are you doing today? Return parser and then return parser.cpp. Okay, so what do we need here? We need a return token, which is a public token, which has a public constructor with a possible value, cc source expose and equals. You also have, let's see if I get the correct neutral, std string override. You have a regular stream schedule. I'm trying to find the rhythm for me. I'm very new to Twitch. I used to stream over on YouTube, but I'm trying to find the schedule. I think around the same time, maybe 2 hours prior to this, or this would be the one we go with. But I have to try out a few other things for me. This should be described. I think the previous streams that I did were, so I tried to do one at 6 hours prior to this. Yesterday I wanted to do one in the afternoon. Well, I live in Canada, so that would be GMT late night, something like that. And yeah, that didn't work out for me. Midnight works for me as well, and early morning works for me as well. So, but I think this one's the best schedule so far. Right. So let's do the return token. When I come up with a study schedule, I'm going to add that to the 2H info. And thank you for following. I really appreciate it. Right. So value DC source S, the starting position and ending position. These are everything. Assign value to it, and then this dot cc. Okay, yeah, I think that's everything. Suppose this dot epose. Currently, we're working on 2 projects. The compiler is one of them. I really like the compiler. The other project that I'm working on is A-Life. That's artificial life, which is a simulation. We're working with neural networks there, and we're working with natural selection there. And we built quite a fun thing there. Feel free to check the video of previous streams to see that. It's really fun to see how they learn to stay alive and survive. Right. So, how do we describe the return token? We are going to say return, and depends whether we have a value or not, because the values are optional, right? So if we don't have any, if we have a value, hang on, can I do it like this? I'm just curious. Does this work actually? No, it doesn't work, and it shouldn't work, right? So let's bring the plus here, and this would be an empty string. Return token capital T. So that's the return token. And how are we going to handle that? So here, I am going to return a parse result of a new return token. The value is null, ccs. The starting position would be temp dot token expose and temp dot token depose. Oh wait, this I made a mistake. Let's undo this, go back to what we were, and come to here. Right, because this has value, right? This one doesn't have value, right? So auto ends. If no ends, return that. Otherwise, return this. And don't look at temp, look at ends. Don't look at temp, look at ends. Right. But if you go here, there is a value, and we have to capture the value. So the value is tuple token star temp e2. That's the value, right? And this is the token. And we would return basically the same thing. We percent and then back copy. So we will return same thing. Instead of ends, we will write temp And instead of 0, we will write v. And that comment is really useful, so I'm going to handle it there. So, okay. So we should see a better return statement, and that should be the end of our stream for today. If it works. Otherwise, we are going to try to debug it. Right, so that's an empty return statement, and that worked. And this is a return statement with a value, and that worked as well. Awesome. Wow. I'm really proud of myself for today's stream. We managed to stream for 2 hours and a half, and we managed to get everything done. Is there anything you guys want to talk about? Or maybe the next 10 minutes or so? Otherwise, we can conclude the stream here. Anything you're interested in seeing? Do you have any question about the language? Or do you want to see a working example? Because this is a implementation. Have you got any resources on how to start with low level? I mean, writing compilers. Right. So writing compilers depends on what type of compiler you want to write. Let me comment this and I'll answer that question for you. Edit assign token, pointer token, and return token. Like so. Good job. Thank you, Crazy Phantom. So, results. Depends on what type of compiler you want to write. So if you want to write a, if you're new to this, I suggest you write a basic interpreter and don't think about compilers at first. So parse a string, any string, and try to run that, right? So I would, for example, write a basic calculator or maybe a calculator that can call functions. You'll start small. And then after you've done that, so you familiarize yourself with how to parse the input, how to process them, how to check for common errors. So after you've done all of that and you familiarize yourself, if you want to write a compiled language, you can start looking at the LLVM's tutorial. So that's a really good documentation there, and they do a really good job of describing what you should do. The only downside to that is that they don't really describe how to parse the language, and you can do that either through Bison and LLVM, Bison and Flex. So we have a working example in the old branch here. If you go to the old branch of Roomy, you have a Lexer and you have a parser here that uses the Flex and Bison to do their thing. And that's an easy way to get started, right? And then you can basically either use LLVM to compile to bytecode, or you can do whatever you want. But that should get you started. Thank you, Mr. Redmaker, for the food goal. I appreciate it. Right. Feel free to check the old branch out. Oh, I don't want to do that. Feel free to check the old branch out. We have a lot of useful. We have done a lot of useful things there. All right, folks. I think that should be it. Thank you for coming here today. I really appreciate it. Hopefully, we can see each other again tomorrow. 2 hours and a half prior to this, or maybe a little bit later, depending on how my schedule goes. We'll see. I really appreciate you guys coming over. See you guys. Bye bye.